We are continuing with another day of finding the missing measurements on scale drawings and scale models. You guys did really well on Friday, and we're going to continue to practice. Remember that scale drawings and scale models used to represent objects that are too large or too small to be drawn to an actual size. A scale gives the ratio that compares the measurements of the drawing to the measurement of the real object. Oftentimes, as you saw on Friday, the scales or the ratio was actually noted that the scales of some number of inches, let's say it's 1 inch, represents some number of feet. It's not always going to be inches and feet. It could be centimeters and meters. It can be inches to miles. It can be any unit we use for measurement. And where do we see examples of scale drawings or scale models? Did you come up with any new ones over the weekend? If so, let us know. The same steps that we did on Friday are the same ones we are going to be applying to today. We're going to be setting up a proportional 1 table, cross-multiplying and dividing. But before we move on to actually setting up and solving some of these proportional relationships, I wanted to cover a few helpful items for you before we get started. I wanted to let you know that an extra note: when you divide by a fraction of maybe 1/3, this is the same thing as multiplying by 3. If you divide by 1/4, this is the same thing as multiplying by 4. If you divide by 1/2, this is the same thing as multiplying by 2. This might help solve some of your proportions a little bit easier. I know sometimes we are not comfortable with fractions, so dividing by a fraction, instead of, we can multiply by the whole number at the bottom, as long as your numerator is 1. Let's look at number 1 together. On a map, the distance from Falls City, Texas to Pleasanton, Texas measures 2.5 centimeters. What is the actual distance if the scale on the map shows 1 centimeter is equal to 30 kilometers? The ratio is together. It usually will be when you're reading these word problems. I can't say that it always will be, but it usually is. We're going to set up our 1 table. And one of the things that I noticed on Friday that you guys were forgetting to do, and that is to make sure you put your labels in. We do this to make sure that all the same units are in the same rows. I also want to make sure that you keep the ratio or the scale together in the original column. It just keeps it consistent, and when we can practice something the same over and over and over again, we become real successful at it. So 1 centimeter and 30 kilometers. They then tell us that it's 2.5 centimeters. So we want to make sure we keep centimeters with centimeters. The x is the unknown. We can now cross-multiply. 1 times x equals 30 times 2.5. The great thing about the coefficient being 1, all we have to do is multiply. There is this thing we call invisible math, whereas 1x is equivalent to x. It really doesn't matter that you see the 1x because anything times 1 is itself. So we consider that invisible math. I can multiply 30 times 2.5. And remember, since I have one number behind my decimal in my problem, I need one number behind the decimal in my solution. Therefore, x is going to equal 75 kilometers. Let's look at number 2 together. I want to look at this one with you since we do have a few fractions in here. If you would like to convert these to decimals, you are welcome to. I prefer to keep them as fractions. I do know that since all I'm doing with solving proportions is multiplying and dividing, I am going to convert any mixed numbers into improper fractions. I notice that I have 3.5 feet. A scale model uses the scale. See, they're going to give it to us. They tell us what it is. But it's a scale of 1 inch equals 3/4 feet. What is the length of the model in inches? We can set up our one table. Do not forget your labels. We want to make sure that we keep everything together as best as we can. I want to keep my scale as my original values. I know that 1 inch is equivalent to 3/4 of a foot. And the 3.5 feet, I can convert 3.5 feet to an improper fraction, doing what you guys like to call the Texas popcorn method. It's 2 times 3, which is 6, plus 1 is 7/2. So I am going to use 7/2 feet and x. I'm going to cross multiply. Do not let the fractions be intimidating. We have multiplied and divided by fractions before, so we are going to continue to use those same rules. I do know that 3/4 times x equals 1 times 7/2. And remember, we just talked about that invisible math. So I know that 1 times 7/2 is equal to 7/2. So that's 3/4 times x equals 7/2. I am going to be dividing by 3/4. We talked about this in chapter 2 and chapter 1. This is called a complex fraction. It is still 7/2 divided by 3/4. And remember, we never actually divide fractions. You have to, you guessed it, keep, change, flip. So we are going to keep the 7/2, change the division to multiplication, and flip the second fraction to 4/3. I could simply multiply 7 times 4 and 2 times 3, but I prefer to cross-simplify to make my multiplication a little bit easier. So I'm going to simplify 2 and 4 both by 2, and since 2 divided by 2 is 1, 4 divided by 2 is 2. I can now multiply 7 times 2 over 1 times 3 and get 14/3. So I do know at this point that x equals 14/3, but right now we do not leave improper fractions. I do need to convert this to a mixed number. I know that 3 times 4 equals 12. 3 times 4 equals 12. I'm going to subtract 12 and I get 2 remaining, and my denominator stays the same. Therefore, my solution is 4 2/3 inches. I do know these problems are lengthy, and it does seem like it is going to be a lot of work. We are applying skills that we learned in Chapter 1 and in Chapter 2. I warned you that these skills will not go away. We will continue to work on them and continue to use them. Do you have any questions for number 2 at this point? Let's look at number 3. An engineer makes a model of a bridge using a scale of 1/3 inch equals 3 yards. The length of the actual bridge is 45 yards. What is the length of the model in inches? I like this because we just talked about, I know I'm going to be dividing by this 1/3 of an inch at some point. And remember, if you go back to the top of your paper, we said if you divide by 1/3, it's the same thing as multiplying by 3. So I'm going to set up my proportions so I can keep my information organized. This is just a tool we use to make sure that we organize our units and keep the scale ratio together in the original column. I know that I have 1/3 inches and 3 yards. They gave me 45 yards. I am going to cross multiply, and I get 3 times x equals 1/3 times 45. Now we are multiplying by 1/3. And the reverse is going to be true in a situation like this, so we can talk about what we noted previously. Let's go back to the top of our page and write a few notes about this as well. I would like to make another note that if you are going to multiply by 1/3, this is the same thing as dividing by 3. If I'm going to multiply by 1/4, this is the same thing as dividing by 4. And guess what? If I multiply by 1/2, it's the same thing as, you guessed it, dividing by 2. So we are going to use this concept to help us finish number 3. On number 3, let's look at this 1/3 and 1/3 times 45. We just talked about multiplying by 1/3 is the same thing as dividing by 3. So I could say that 45 divided by 3 is equal to 15. So as I continue with my equation, I have 3 times x equals 15. That seems a little bit more simple. To finish off my equation, I must divide by 3, which is the coefficient. Therefore, x equals 15 divided by 3 is 5. Let's go ahead and show our work that 15 divided by 3 is equivalent to 5. Therefore, our answer is 5 inches. What questions do you have at this point? Let's see if you can do number 4 by yourself. This one was very much like your problems from yesterday. Did you make sure that you labeled your tables, kept your centimeters together and your meters together? Sometimes we like to forget to divide by the coefficient. So make sure you are dividing by the coefficient to get the answer of 7 centimeters. Now let's see if you can do number 5 by yourself. Do not forget to convert the 9 2/5 inches into an improper fraction using the Texas popcorn method. This was a tough one. It did require for you to remember many steps that we used in Chapter 1. But here's the reward. You do have an invisible 1. Remember our invisible math? Anything times 1 is itself. So lucky for us, once we got through with multiplying 9 times 47 over 5, we were able just to convert that improper fraction to a mixed number, and we have our answer. Do you have any questions at this point? Let's try number 6 by ourselves. Number 6 was one of these problems where you were going to be dividing by a fraction with a numerator of 1. And if you can see, I did cross multiply, so I got 1/2 times x equals 4 times 1. I solved that, simplified that to 1/2 times x equals 4, and then I divided both sides of my equation by a half. But I remembered that dividing by a half is the same as multiplying by 2. This is going to help make it just a little bit easier. So all I did was multiply 4 times 2 and got 8 inches as the answer. Are there any questions? Let's work number 7 through 10 together. Number 7, a model ship built to a scale of 1 centimeter equals 6 meters. The length of the model is 36 centimeters. What is the actual length of the ship? This one is very much like the ones we did yesterday, but I still want to make sure that I keep my scale together. I'm going to have centimeters to meters. I'm going to keep my scale inside of my original column, so 1 to 6, and they give me 36 centimeters. So I want to make sure I put that in the correct place in my table as well. I can cross multiply. 1 times x equals 36 times 6. And I think this is great because, again, I have an invisible math situation where I can just take the 1 off, and then all I'm going to do is multiply 36 times 6. Therefore, the answer to this problem would be 216 meters. Let's see what we can do with number 8. Danny wants to build a model of the Smith Tower. The Smith Tower is 174 yards tall if the scale is 1.5 centimeters to 3 yards. How tall will the model be in centimeters? Well, we're going to set up our table. Keep my words are my units. It's centimeters to yards. My original is the scale. So I'm going to keep my 1.5 centimeters with my centimeters and my 3 yards with the 3 yards. They told us previously that it was 174 yards tall. So once I have my proportions set up, I can cross multiply. 3 times x equals 1.5 times 174. I'm going to do this math over here off to the side. So I'm going to have 174 times 1.5, 35, 36, 37. 5 times 1 is 5, plus 3 is 8. Use my placeholder 0, so I can multiply 1 times 4 is 4, 1 times 7 is 7, and 1 times 1 is 1. Add up the product of those two numbers. 7 and 4 is 11. 8 and 7 is 15, plus 1 is 16, and 1 and 1 is 2. But remember, if I've got one number behind my decimal in my problem, and one number behind my decimal in my solution. So right now, I have 3 times x equals 261. Now what is the next step? You guessed it, I have to divide by the coefficient of 3. I'm going to go ahead and do that math over here as well. So 3 going into 261. And remember, it's top in, bottom out. 3 does not go into 2, but it goes into 26. 8 times. Subtract 24. 26 minus 24 is 2. Bring down the 1. 3 goes into 21 7 times. And I have nothing for a remainder, which is great, because then I don't have to add any decimals or zeros. But I do find out that x is 87 centimeters. Are there any questions on number 8? Let's go through number 9. Nancy is driving to Mount Elbert. On her map, she is a distance of 9 inches away. The scale of the map is a half inch equals 50 miles. How far must Nancy travel to reach her destination? Well, I can set up my proportions like I always do. Again, I want to keep my units together. So I have inches and miles. I'm going to label just as an organizational tool. Keep my scale in my original column, where I have 1/2 inch to 50 miles, and they told me that it was 9 inches. So make sure you keep inches together and miles together. Now I can cross multiply. So I have 1/2 times x equals 9 times 50. And then 1/2 times x equals 9 times 5 is 45. And I can add the 0 on the end. Oh goodness. Now I am going to be dividing by 1/2. And remember what we said at the very beginning? A little note, when you divide by a half, it's the same thing as, you guessed it, multiplying by 2. So dividing by 1/2 is equal to multiplying by 2. So instead of dividing this, what I will do is I will say that it is 450 times 2. I know that 45 times 2 is 90, and I'm just going to add that 0 on the end. So I know that Nancy needs to travel 900 miles. Let's see what we can figure out about number 10. A pond dug according to plan with a scale of 1 inch equals 5 feet has a maximum distance across the pond of 9 and 7/500 inches on the plan. What will be the actual maximum distance across the pond? Alright, well, I'm going to set up my proportions. I am comparing inches to feet. I have 1 inch is given to me in the scale equal to 5 feet. You want to make sure you keep that in your original. And the 9.75, is it inches or feet? Very good. It is. It is 9.75 inches. So you want to make sure you keep it with your inches column, and we will be looking for the equivalent number of feet. I can cross multiply. I get 1 times x equals 9.75 equals 5. Oh goodness, and what is that 1 considered there? That is correct. It is invisible math. So once I multiply these two numbers together, I know that I do not have to divide. So I'm going to come over here and do my math of 9.75 times 5. 5 times 5 is 25. 5 times 7 is 35 plus 2 is 37. 5 times 9 is 45 plus 3 is 48. But how many numbers do I need behind the decimal in my solution? That's it. I need 2. I need 2 numbers behind my decimal in my solution because I have 2 numbers behind my decimal in my problem. And you guessed it. The answer is 48 and 3/4. So 48 and 7/500 actual feet across the pond. Couple of things that you want to make sure that you remember is make sure that you are putting your units in the table as you go along. I want to remind you that that was one of the problems that we were having on Friday, is that without the units in the table, many of you were putting this third number into the wrong row. That table is nothing more than a tool to help you keep your information organized. Make sure you are cross-multiplying and dividing by the coefficient. If you need any help, please make sure you raise your hand and let me know.